Reading in Data 1. For this demonstration, I'm going to be working with a simple data set that I'm calling BP for blood pressure. There are 5 observations and 5 variables in the data set. The first variable, clinic, is represented by a letter. And then there are 4 numeric variables for diastolic blood pressure at 6 months, systolic blood pressure at 6 months, diastolic blood pressure at baseline, and systolic blood pressure at baseline. In this first example, I am going to show in-stream data where the data is separated by spaces. Character variables are indicated by a $sign after the variable name, and the period is used to indicate missing data. The statement in file data lines tells SAS that the data is in-stream, and it's optional here. You don't need this in-file statement when you're using data that's within the program itself, but it's helpful if we want to add some additional options, which we'll be doing later on in the demonstration. So here I'm creating this data set called BP, which is a temporary SAS data set, and that means that the data set is only available during the SAS session. It's not saved as a permanent data set in some other location. So let's highlight this area that I'm going to run this bit of code for you, and then let's see what happens. Okay, so we see here that we have a printout of the data where I used the input statement included where the data was separated by spaces. And notice that we have 2 missing variables for observation 4. Now let's take a look at the log. And it says here that there were 5 observations read in from the data set work.bp. Anytime that SAS is creating a temporary data set, it automatically attaches the prefix work to the data set. And so if we go back to our program, you'll notice here that I have added this comment where I say that you could have also written data work.bp, and that would have created the same data set. So when creating a temporary data set, either type in the data set name or the data set name with the prefix work. Now let's go down to this second example, and here we're looking at list directed input, so it's in-stream data, where the data is separated by commas. So here, in order to tell SAS that our data is separated by commas, we have to add an option to our in-file statement. And the option is DLM equals, we're telling SAS that the data is separated by commas. Notice that we still have our missing value of a period that's separated by commas. So let's highlight this bit of code here and run the program. And here we see reading in data using list input where the values are separated by a comma. So again, we're getting the exact same output. We've just structured our data differently for SAS to read it in. And again, our log says that there were 5 observations read from the dataset work.bp. In this third example, we are reading in data that's similar to the kind of data you might get if you were exporting it from Excel or a different kind of spreadsheet, where the data was saved as a CSV file. So if you ever see a data set with an extension CSV, this would be the kind of code you would use to read in that data. So here, again, like in our previous example, data is separated by commas, but notice that consecutive commas are used to indicate missing data. So here in our 4th observation, we have consecutive commas, but there's no period to indicate that the variables are missing for 2 of them. For this type of data, we use the DSD option in the in-file statement, and it assigns missing values when multiple delimiters are found. It also assumes the delimiter is a comma. So actually, for this particular code, you don't need the DLM equals option. We could actually delete it and just have the DSD option. Besides assuming that consecutive commas have a missing value, this option also strips off quotes from character variables if they are present, and it ignores delimiters in data values enclosed by quotation marks. So if you had a character string with a comma inside the string, it would ignore that delimiter. So let's run the code for this example. Again, we're getting the exact same printout we've seen before, except now we're reading in data that's separated by commas, where consecutive commas indicate a missing value. And so we're using the DSD option on the infile command. Now in this next example, you're going to see the data structured in a much different way. And normally, if you're reading in-stream data, you're not going to have the data set up like this. This is just for illustrative purposes. But very often, data that comes to you from the government can come in fixed columns. So we refer to this as column input. We're reading data positioned in fixed columns, where the user needs to specify the beginning and ending positions. Character variables are followed by a $sign after the name, as we've been doing before. And note here that each variable has to be in the same position in each row of the data. Also notice that missing data can be represented by blank columns. With this style input, you can also skip to any desired column or go to a previous location in a given row of data to read in values. You will definitely need a code sheet with column locations. So here, for example, we're reading in the variable clinic, which is a character, and it's in column 1. Diastolic blood pressure at 6 months is in columns 2 to 4. Systolic blood pressure at 6 months is read from columns 5 through 7. So we're 3 positions for systolic blood pressure, and so forth. So again, let's highlight this code and run it. And again, we come out with the exact same print out of our data as we have in our previous examples. The only difference is that the data is now structured such that we have to use column input to bring it into SAS. An alternative way of reading in data, which is in fixed columns, is using pointers and informats. An informat is a way to give instructions to SAS for reading in the variable. Here we are using this @ statement to tell SAS what column to start reading the variable. And then we are providing an informat or an instruction to SAS to explain what the variable is. So here at column 1, we are reading in clinic, which is a character, and its length is just 1. Here from column 2, we're reading in diastolic blood pressure at 6 months, and the informat is 3.0. This means that diastolic blood pressure has a width of 3 with no places after the decimal point. And you alternatively could have just said 3 point, which would also tell SAS that we have a number that has a width of 3 with no places after the decimal point. So using pointers and informats is another way of reading in data that's in fixed columns. So here let's again highlight this bit of code, and we see once again that our data looks exactly the same as it has in all the previous examples, but we've read our data in using pointers and informats. So I've shown you at this point many different ways that we can read in the exact same data set, but how the data set can be presented differently. And the way it's presented differently is how we have to provide SAS with instructions to read it in so it prints out the way we want it to print out. In all of these examples, the data is in-stream data. So we have a data line statement with the raw data following the data line statement, and then a semicolon on a line by itself. We're now going to switch and take a look at how we would read this exact same data if it were from an external file. So if the data exists in an external text file rather than in the program, we're going to need to use the infile statement with the directory path and file name of the file in quotes. So let's say we had saved our data. It was originally in Excel, and we saved it with a CSV extension. Excel automatically creates a file with the names of the variables as the first row of the data. So we're going to want to skip this row by using the first OBS option because we want to start reading our data where we actually have raw data and not the column headings of our data. So here is an example of a file called bp.csv. So this was a dump of data from an Excel spreadsheet where the first row lists our variable names and then the next 5 rows are our raw data. And notice again we have the situation where consecutive commas indicate that there's a missing variable. So here's how our code has been altered to read external data. Now it's imperative that we have an in-file statement. It's not optional. And so the in-file statement tells SAS where to find the data. We use the DSD option to tell SAS that it's comma delimited and consecutive commas indicate a missing variable. And we're also telling SAS to start reading the raw data at row 2. And notice here you don't have a data line statement because we are getting our data from an external file. So we're going to highlight the code, run it, and we see here that again the data looks exactly the same as in the other programs I've showed you. Now let's take a look at the log. Here the log says that if we go up here we see that 5 records were read from the in-file statement, so from this location. And it tells us that SAS created a data set, work.bp, that has 5 observations and 5 variables. So we see here that the log tells us that the data was read in from this external file and it looks like it was read in appropriately because we expected 5 observations and 5 variables. An alternative way to read in data from an external file is with a file name statement, which defines a file reference to the external file. The file reference is used on the in-file statement, and the file reference name can be a maximum of 8 characters long. So here is our file name, and then our reference is a name that I'm calling BP data to stand for blood pressure data. And then I'm giving the location where this data set is. Then notice in the program, instead of having in file and listing the full path where the data set is, I am just using the reference name BP data. So it's matching the reference name I've used in the file name statement. And once again, I have to include the options DSD and first obs equals 2 to tell SAS that our data is comma delimited with consecutive commas indicating a missing variable, and also that our raw data begins in row 2. So again, this is just an alternative way to read in this file which has an extension CSV. So let's highlight this code and run it. And we see here again that we've read in data from an external file using a file name statement. Once again, if we were to look at our log, we see that with the file name statement, again, we can read in our log that 5 records were read in, that the data was gotten from this location, this path name, and that 5 observations were printed out, and that the data set that was created was a temporary data set called work.bp. This last example I'm going to show you is totally different from what we've been looking at before, where we've had data statement and an in-file and an input statement. Here we are using a procedure, the import procedure, to read in data. The following code will read the file listed under the data file name and create a SAS dataset called BP. The DBMS parameter indicates the type of external file. So here if we look at this procedure, proc import, we see that the data file exists in this location. We want to create a SAS temporary data set called BP. The DBMS option tells us it is a CSV file, and the get names equals yes tells SAS to read the variable names from the first row of the data set bp.csv. The replace option tells SAS that every time you run this code, replace it with the new data set. So it's like you're overwriting the data set. The little SAS book goes into much more detail of proc import. I'm showing it to you here. This is not going to be the most typical way that we read in data in this class. So most of the homeworks and examples I go through are going to look more like the examples I've shown you previously. But I did want to provide this example because it's indicated in your book and it can be helpful at times. So let's run the code proc import. And we're just going to go through the proc print. I'm not going to talk about proc contents now because I'm going to talk about that in a later demonstration. So let's just run the code for proc import and then proc print and see what happens. And again, we see the same data, the same for observation 4. We have missings for diastolic blood pressure 6 and systolic blood pressure 6. Notice that the output looks a little bit different from the procedure, but it's just that the columns, the data are spaced further apart, but the exact same output is being shown. And once again, let's check our log. And we see here 5 records were read in, 5 rows were created, and we have 5 observations and 5 variables. And so here we've looked at a bunch of examples using this one data set, BP, for blood pressure, and many different ways that we can read in data into SAS.